Bismillahirrahmanirrahim. Now this is another paper 6 and I'm going to guide you into how to do this paper which is coming very nearby, and we are going to be doing this paper very soon, inshallah. As you all know, the time for this is 1 hour, so you must have this in mind when you're starting the paper, that you don't have much time to do this paper and you must do it as quickly as possible, and do not sort of wait when you don't know the answer. Just go on to the next part and then come back to the one in which you're not sure of the answer. Now, as you all know, we have to do all the questions in this. There's no choice in this, and you have to do it on the paper. Question number 1: when tissue is cut, the cut surface turns brown. So, important that we know that it turns brown. This is because enzymes are released when you cut an apple. Enzymes are released which cause reactions between chemicals in the plant and oxygen of the air to produce brown substances. The photograph below shows 2 slices cut from a banana. Slice A was exposed to the air for 2 hours and slice B was freshly cut. The freshly cut slice has a creamy, slice B was freshly cut. So this was a creamy yellow color. Creamy yellow color. Right? Since slice A was exposed to the air for 2 hours and B was freshly cut, the freshly cut had a creamy yellow color. We don't know the color of this as yet. Some students decided to investigate the effect of different treatments on the rate at which a banana turns brown. They cut 3 slices from the same banana, each 1 centimeter wide. So the banana was 1 centimeter wide. One slice C was placed in a beaker of dilute HCl. So slice C was placed in dilute HCl for 2 minutes. It was then removed and placed on a white tile. Slice D was placed on the white tile and cut into many small pieces. The third slice E was left untreated on the white tile. The student observed the slices and recorded the color of each after 5, 10 and 20 minutes. So 3 readings. After 5 minutes, they also measured and recorded the pH of the cut surface of each slice. So after 5 minutes, they also measured and recorded the pH, 5 minutes. But actually readings were till 20 minutes. After 5 minutes, the results are shown below. After 5 minutes, HCl treatment pH 2, creamy yellow cut up slice, pH 6, very pale brown untreated slice, pH 6, creamy yellow. After 10 minutes, HCl treatment creamy yellow cut up slice, pale brown, untreated slice, very pale brown. After 20 minutes, HCl treatment creamy yellow cut up slice, brown, untreated slice, pale brown. So now we have to look at what was given to us and what have we to figure out. So the first is creamy yellow. I would circle this. Then I will cut up slice, pH 6, very pale brown, untreated slice, pH 6 and creamy yellow. So I would spend a little time on this because you can see that the next part of the question is going to be about this, making a table of this, which we all know they do very often. So this is exactly what they asked you to do. Enter the student's data. Enter the student's data in the table. So you've got to get it from the previous one and put the data here. So this is the table which you should have done. This is for 3 marks. Now both tables with values in every box, all colors correctly entered and all pH correctly entered. So you got 3 marks for these 3 mark scheme points which I've just mentioned, is that both the tables with values in every box and all the colors correctly entered and all the pH correctly entered. So this got you your 3 out of 3. Now you should have done this paper before you start watching this video. Somebody has commented in one of my videos that you should give time for that. I expect you to do the papers first on your own, do it in writing, and then look at my videos which are explaining the different parts of the question. The untreated slice E was the control in this investigation. Explain why this was included. Why is it included? To compare. C for control, C for compare. To compare the effect of the treatments with no treatment. Then part 3. The banana slice C was placed in a small beaker containing 50 cm³ of dilute HCl, hydrochloric acid. Name the piece of apparatus you would use to measure accurately 550 cm³ of dilute HCl. So you're measuring a fluid. How do you measure a fluid? You use a measuring cylinder. So you use a measuring cylinder to measure 50 cm³. Then part 4, describe how you would safely remove the banana slice from the HCl. What will you do? You'll use a forceps. You're going to touch it. The acid is going to really damage your skin. So using forceps. So that was a very easy point which you had to remember. You couldn't have said anything else. Now coming to part 5, describe how you would measure the pH of the surface of the banana slice. Now that's 3 marks. So what would you use? You would use either a pH paper, or you could use a universal indicator solution. So use universal pH paper, or you can say is a universal indicator solution. Then what do? You observe the color change. You see what happens to the pH. So observe the color change. And then what do? You use a color chart to compare it with. You've got to think it's 3 marks. So you have to give me 1, 2, 3 marking scheme points. Otherwise, this is not going to get you any marks. B part 1, describe the effect of dilute HCl by comparing the results for slices C and E. With the HCl, it stopped browning. The one which was in the HCl stopped browning. Why? Because the enzymes, the pH was very, enzymes work best at a certain pH, and they get denatured at pH above or below that. Suggest a reason for the effect of dilute HCl. Enzyme denatured. Now coming to part 3, state the effect of cutting up slices D into small pieces by comparing the results with E. So one you didn't cut up, the D, when you cut up the D into small pieces, it turns brown more quickly. So cutting up into small pieces means you expose more area to it. More of the enzyme is available. Increased contact with oxygen, increased surface area. So D turns darker brown. So D turns darker brown or changes color more quickly. Then suggest a reason for this effect. And that's the same thing as more enzyme, or you could have said even more substrate, because you're cutting it up. More enzyme, more substrate is available. It's a slash. Means you had to give me both, you had to just give me one. So more enzyme substrate available, increased contact with oxygen. That got you a second mark, but there's only 1 mark for it. And of course, cutting up the pieces increase the surface area. So I don't mean you have to write all 3 of these to get the 1 mark, but any one of these. So it's not a question of, so any one of these. There were actually 3 mark scheme points, 1, 2 and 3. So there were 3 mark scheme points. Then part C, the students found it difficult to describe their observations in this investigation. Suggest a reason why they found it difficult and an improvement to their method to overcome this. So you see, there could be many things. Number 1, the first reason is color change is not rapid. So record over a longer time. Then difficult to assess the color, so compare with a color chart. Or you can say the color change is not uniform, so assess the area which has changed. So how much area has changed? 20%, 30%, 40%. So because it says found it difficult to describe their observation, suggests a reason why they found it difficult and an improvement. So this will be this will reason, and then the improvement will get you your 2 marks for that. So color change not rapid, so record over a longer time, 1 point. So you will get color change not rapid, relevant reason and relevant improvement. Difficulty to assess the color, so compare with the color chart. And the last is color change not uniform, so assess the area changed, that in one 50% of the area has changed and one 70% of the area has changed. Now coming to the D part of the question, use a method similar to the one in this investigation. Design an experiment to determine the optimum pH for a banana to turn brown. So same story, but it has to assess what is the optimum pH for a banana to turn brown. Well, what are you going to do? First, you're going to think of what is going to be the control. Let's talk about that at the end. The first thing which you've got to do is, because we are studying pH, so then you use different pH solutions. Then you freshly cut the slice and place in each pH. After 2 minutes, you remove the slice and put the slice on a white tile. Then measure the time taken for each slice to turn brown. And pH that goes brown fastest is the optimum. So in whichever pH the brown color appears quickly, that is going to be the optimum pH. So use a method similar to the one. So number one, you take different pH solution, then freshly cut slices and place in each pH. Then after 2 minutes, remove the slices and then put them on a white tile and see how much of the area has turned brown. Either you can say the area has turned brown, or you can measure the time taken. After 2 minutes, if you take it out and put it on a white tile, then of course it is going to be you've taken it out of a specific pH solution. So it is better if you think of how much of the area of it has turned brown. So if you take 5 different pH solutions, pH 5, 6, 7, 8, 9, freshly cut slices, 5 pieces in each pH solution. After 2 or 3 minutes, take out the slices, place on a white tile and measure the time taken for each slice to turn brown. The pH that goes brown fastest is the optimum pH. Now coming to question number 2, a student investigated the effect of exercise on her rate of breathing. She started exercising at 2 minutes. So she started exercising at 2 minutes and stopped exercising at 8 minutes. The data collected is shown in the table. Rate of breathing / breaths per minute. Construct a line graph of the data on the grid below. Join your points with ruled straight lines. Now you know this, what is the rule is, this is the first column and this will always go on the x-axis. The mnemonic is F-I-X, fix. First column, this is the first column. You can see this is the first column of the table, is the independent variable and it is always plotted on the x-axis. Now the other one, of course, this part, the rate of breathing in, this will go on the y-axis. Then look at the figures. This is this one you can see is 0 to 10. So the x-axis, you have to be careful, is that if you write 0 to 4, 6, 8 and 8 and 10, so this would be exact. Then the y-axis, you will have to write the whole, you have to label it rate of breathing in breaths per minute. Now this is between 14 and then 14, 24, 35, 35 and 19. So the highest is 35 and least is 14. Now you've got to spread the scale somehow. So think, how will you do the scale? You must use this entire grid which is given to you. So you've got to be careful how many small boxes it has, and you have to use the whole grid. So you can't just do a graph in this area and just use a little bit of the graph. No. Or you can just say, you can use a little more of the graph. That's the important thing, is that you should use, if the graph is like this, it should be there. It shouldn't be like just in a little place here. That would be wrong. So this is what you have to understand, is that the graph is to occupy the majority of the grid. Then you label the axis. Please remember you have to write the units. The unit is a must that you write the units here. Breaths per minute and time in minutes. Rate of breathing is breaths per minute. And please be careful how you write it. I might not have, this is not one word, so let's write it a little separately. Breaths per minute. And then you write this and you divide the scale. You must look at the highest number here. You can see it's 0 to 10, and this is something to 20. So I would say 20 is the highest. So you've got to decide how you're going to divide the scale. And this is something very simple. In A levels, of course, the Cambridge will give us the scale. So it has to be according to that scale. Y-axis scale was wrong because I didn't see that the highest figure was 35. So I've changed the scale on the y-axis and it is 10, 20. So this would be 0 here for this as well. So 0, 10, 20, 30, 40. So this is how I've changed the scale. And for this, because it was up to 10, so I've got it on the x-axis. Then you plot the points and please do it very accurately. I might not have done it very accurately because of the pointer that I have. And then, of course, all you have to do is connect them point to point with a rule line. Use a ruler to connect the points. So every point must be connected to the next point. So you do it like this here, then you do it like this here, and then you connect this one here, then you connect this one here, and then you bring this down. But you must go through the point. It must not go like the point is here. It must not go below the point. You must touch the point. Like this is the point. This is the point, and you must circle the points. Or you can use a cross, and then you connect the points exactly. Then coming to the next part of the question, use your graph to find the rate of breathing at 5 minutes. So this will be, the 5 minutes will be somewhere here. This will be the 5 minutes. Show your working on the graph. So that's for 2 marks. So you must show your working on the graph that you know, okay, well, you extended this line and you can do it with a sort of dotted line. At times they accept that, or you do it some other way. So this is the one, and then you can see it. It goes somewhere here. So it's about 29 breaths per minute. So 2 marks, 29 breaths per minute. So 29 breaths per minute got you 1 mark. And if you showed me this line on the graph, this dotted line on the graph, then you got that another mark for that. Describe how the student could have measured her rate of breathing. Count each breath over 1 minute. You use a stopwatch and then you say, okay, so you start counting the breaths. So one breath in, about so 1, 2, 3, 4, 5, 6, 7, 8, and then you count it and take the time in 1 minute, count the breaths per minute. Now let's look at the last part of the question. Exercise increases the rate of breathing. State one other measurement that the student could have recorded to determine the full effect of exercise on breathing. The depth of breathing. You see, when you start exercising, the rate of breathing also increases and the depth of breathing also. You take deeper breaths. You take air in and air out. You take deeper breaths. So depth of breathing increases, or you could have said volume of each breath. You see, you might know it, but if you don't know these exact words to use, well, then you're stuck with this. Then you're going to come up with a lot of beautiful stories, BS, and you're not going to get many marks for that BS. In the last couple of years exams, these last 1 year, they've increased the number of questions. So they're usually now 3 questions. I did another paper also, there were 3 questions in that. So in question 3, the photograph shows a leaf of a southern beech tree. And you can see that the teeth on the leaf. Now be very careful. As I always say to you, you think as if you are actually tracing this. So if I trace this, then you can see how many sort of indentations does it have. So they must be exact. How many are they present on one side and how many are they present on the other side? Now you can say here 1, 2, 3, 4, and here we have 1, 2, 3, 4, and there is the fifth one here, which was the tip of it. So Drawing should be at least 8 centimeter long, drawn with a sharp pencil, continuous line, no shading, leaf length greater than the width, and a stalk drawn with double line and closed at the end. Then 4 teeth on the left side and 5 teeth on the right side. So let's see if there are 4 on the left side and 5 on this side. Let's look at it carefully. Yes, they're right. So this is 1, 2, 3, 4. And here we have 1, 2, 3, 4, and 5. So it says 4 sort of teeth on the left side and 5 on the right side. Smooth edge to the leaf, and first point on the right is higher than the left. So the first point on the right is higher than the left. You can say I've tried to make a diagram. I'm not saying it's one of the best of the ones, but you should fill at least two-thirds of the space provided. It was at least 8 centimeters. So you see, you have to, there's a least, but there isn't a maximum, there's a minimum at least. So you can't draw a very tiny sort of a leaf like this and just draw a very tiny one. That would be out. Then draw with a sharp pencil, continuous lines, no shading. Then leaf length should be greater than the width. Then the stalk drawn, this doesn't look a little greater than the width. Maybe you need to make it a little more longer. So leaf length should be greater than the width, and stalk is drawn with a double line and closed at the end. So this I have closed at the end here. I have closed this here so that you can, this is closed. Then the 4 teeth on the left side and 5 on the right side. Then smooth edge to the leaf and first point on the right higher. This first point should be higher than the left side. So this is how you have to do the drawings. Nothing very difficult, but just sort of just trace it out like you would do a tracing of the picture given to you. Then coming to part 2, on the photograph, draw a straight line to join F and G, measure and record the length of the line. So you have to draw this here. This is F and G, so you have to draw the line from F to G. And of course, it should be a straight line. So draw a line FG, and then you measure this, you measure the length of it. So this was about, I think so, this was about 34 millimeter. On your drawing, draw a straight line in the same position as on the photograph, measure and record the length of the line. So then I would do it on this, and I would draw this line here, and I would measure the length of this. Now, I'm assuming, I'm not sure what the length is, but say this is double the size of this, so it is 68 millimeter. Now calculate the magnification. You know magnification is equal to image over actual, but then let's look at this. If this was magnified only one times, so one time was magnified. So then what do you do? Image over actual. So you do 68 over 34. And this is equal to, so it is magnified 2 times. Biological keys can be used to identify species. A biological key for 5 different species southern beech tree is shown below. Use this key to identify the name of the tree whose leaf is shown in the photograph on page 8. To use the key, start at 1 and read the 2 alternatives. Decide which one is correct and tick the box next to the option. If indicated, go to the next number. Continue with this procedure until you identify the tree leaf in the photograph. So leaf with a smooth edge, leaf with teeth on the edge. So you had to put a tick, leaf with the tick here. Why? Because it's got teeth on the edge. So now you go leaf with the, go to 2. So now we go to 2. Leaf 20 to 40 millimeter long, 16 to, so you know that it will be A because it's about 34 or something like this. Then you go to 3. Leaf with 4 to 7 teeth on each side. Leaf with 8 to 12 teeth on each side. So it had 4 to 7 teeth. So this is red beech. So you see, you had 2 marks. So if you got these two correct, this was 1 mark. And then if you got this correct, this was 1 mark. So a total of 2 marks. So you've got to think how they're going to give you these 2 marks. So this was a 12-mark question, and this finishes your ATP, and this was going to be for 1 hour. So please, kids, remember that you can't sort of do it very slowly. You have to do it pretty fast and then go back to the ones where you are struggling with some sort of answers. The drawing should be done, the graph should be done first. I would prefer that you do the graph and the drawing first so that then you can concentrate on the rest of the paper. Because that's a very easy marks, 4 marks for the graph and 5 marks for the drawing. So that was a very easy marks which everybody should get. Thank you for watching. Thank you for subscribing, and wish you all the very best and best of luck in your exams. All my prayers are with you all.